All right, good morning, everybody. Excellent, there we go. So, you know what's happening, the Wi Fi issue again. So, we're going to just move as such and make sure you're still given the proper notes. All right, so we're on number theory, which is what we've been doing. All right, we've been talking about sequences. We've been talking about sequences, and we gave examples such as 2, 4, 6, 8, and each value in this sequence is called a term. You learned that. Alright? Each value in this sequence is called a term. Okay, excellent. But here's also, we need to find what rule is there to determine what's the second term. Because this is term 1. You know, term 1 is going to be equal to 2. But what is the rule to find term 2? Which is 4. So therefore, we found that the definition of the rule in any arithmetic sequence, can tell you what the next term or what any term will be. In the arithmetic sequence, can tell the next term or the nth, put in bracket, the nth term, which means any term in that sequence. So the rule in this case would be I need to add 2 every time. So therefore the rule is n plus 2. Any value n plus 2 will tell me the value in the next sequence. Alright? So if I had the third term, so T3, so if I want to find the third term rather, I would say term 2, which is the 4 plus 2, which would be equal to 4 plus 2, which would be equal to 6. T3 is equal to 6, and we see that's true. So this is what we've been going through. Alright? We can take that out. Now we're going to continue and look at the types of sequences. Types of sequences. Alright, types of sequences. Here we go. Types of sequences. Alright, here we go. Let me just scroll down for you. Right. So the first type of sequences that we're going to learn is arithmetic sequence. Arithmetic Alright. Now, as the term suggests, it has to do with operations, arithmetic. Alright? Now let's read it quickly. In this type of sequence, it follows a pattern of adding. Alright? A fixed amount from one term to the next term. So the example where I gave you 2, 4, 6, 8, we add it each time to get to the next term. In this case, 2 to 4, 4 to 6. All right? It says the number that is added to each term is constant. So we know it's always going to be 2. The constant value is called the common difference and may take any value, positive or negative, or even a fraction. Let's give an example of a positive common difference. A positive, so take this note out for me, positive common difference and then we're going to give a negative and a fraction. But let's start off with positive common difference. So let's go back to the same type of number. Let's do a 3, 6, 9, 12, 15, 18. There's a total of 1, 2, 3, 4, 5, 6 terms, right? So we term 1 and this will be term 6. Now the positive common difference, right, would be an increasing sequence that is added each time of positive 3. So if I want to find, for example, the term 2, the rule is to have a positive common number of 3 added. I'm going to say term 1 plus 3. If I want to find term 3, that's going to be term 2 plus 3. Let's do one more. If I want to find term 4, that is term 3 plus 3. So throughout, we see a common value of 3, which is added each time to the sequence. And that's why it's a positive common difference. All right? The next one that we're going to be looking on is a negative common difference. So quickly take that off for me. We're going to look at a negative common difference. Alright, let's look at a negative common difference now. Negative okay. Now, the term negative, if I was to give you a number line and say this was 0, if I continue to say 2, 3, positive, positive 1, positive 2, positive 3, right? The negative of this would be not going right, but instead going left. So this would be negative 1, negative 2, negative 3. And you should know that this is called an integer. We have positive numbers and negative numbers. These are called integers. Quickly. So let's quickly write the definition of integers. Let's scroll back up. I have it right here. So an integer for integer so an integer is a set of positive and negative numbers. So here's an example. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Right? So integers are a set of positive and negative whole numbers. So sets of positive and negative whole numbers. Okay, excellent. Now that we know what is a positive number and a negative number, let's try to find a negative common difference example for an arithmetic sequence. Let's go. Okay, so here we go. All right, here we go. So these are two examples. These are example one. This is example two. All right. The rule for the first example, -1, -2, -3, -4. I am not increasing, but rather I am decreasing each time. Because if you realize, when I'm going to the right of the number line, starting from 0, that is how I increase. If I go to the left, so let's say I had 2 right here. If I was going to the right, that would mean I was increasing to 3. But if I went to the left, I would be decreasing to 1. Alright? So take this example though. If I have -1s, -2s, and -3, that means I am still going to the left. I am still decreasing. So that's why this is a negative common difference, because I am not positively increasing. Alright? Now, what is the rule for example 1? I'm going to give you 2 minutes, 2 seconds to guess it. -1, -2, -3, -4. What is the rule to get to the next term? The rule is to subtract 1 each time, or add a -1. It's the same connotation. So the rule is term 2 is equal to term 1 minus 1. Term 3 is equal to term 2 minus 1. Term 4 is equal to term 3 minus 1. All throughout, we see that the common value is -1. Now you might be saying, sir, why didn't you start off with term 1? Is it because it won't work? Well, actually, it will work, because term 1 always starts from 0. So I'm going to say term 1 is equal to 0, or term 0, right? So I could call this T0 or 0 minus 1. What is the answer for 0 minus 1? It's going to be -1. What is the answer for -1 minus 1? It's going to be -2. What's the answer for -2 minus 1? It's going to be -3. Finally, -3 minus 1 is going to be -4. Alright, and that's our trend. Because if you look now, based on this value, that's our example 1. Alright, quickly turn that off for me. Yes, quickly turn that off. Alright, good. And the last one, we're going to have a fraction common difference. Fraction common difference. Okay, fraction common difference. Now, let's quickly go back to where we started. All right. All right, follow with me. A fraction common difference is gonna be a case where my next term is either increased or decreased by a fraction. So if I have a half, right, and then I turn to a quarter, and then I turn to an eighth, and then I turn to a sixth, and then I turn to an 8, right? What is the rule in this example? So a half, a fourth, a sixth, and an eighth. You add by an half each time, right? So term 2, let's start with term 1, is equal to 0 plus a half. Term 2 is equal to term 1 plus a half. So a half plus a half will give me a quarter, that's true. Term 3 will be term 2 plus a half. So a quarter plus a sixth will give me an 8. Sorry, a quarter plus a half will give me a sixth. Alright? And then now finally term 4 would be term 3, which is a sixth. So T3 plus a half. So 1 divided by 6 plus 1 divided by 8 will give you, 1 divided by 6 plus 1 divided by 2 would give me 1 divided by 8. And that's my answer. Alright? That was fraction common difference. So the common difference is a half each time. And these 3 examples that I gave you a while ago was arithmetic sequence. So we're going to form a definition for arithmetic sequence to say we increase by a constant value. So we increase, so this is the note briefly. Note briefly. We increase, right, by a constant value, and increase could be decreased, really. Alright? So we increase or decrease by a constant value. Okay? So we increase by a constant value through addition. You might be saying, sir, if I am adding each time, how do you explain a negative common difference? Let me go back to that example. -1, -2, and -3. This is just to clear some plot holes. So if I add -1 plus -1, this is technically addition, so I'm sticking with the rule of adding. But when I add 2 negatives, the rule is that they're going to be a negative. So negative plus a negative will give back -2. Alright? That's just to clear a plot hole if you think I made a mistake. Alright, good. So the next type of sequence, that we're going to go through is going to be decreasing. Yeah, we did that. We did that. So that was an increasing sequence. We did decreasing sequence. So an increasing sequence, let's just quickly define it. An increasing sequence, as the term suggests, is where you are between any 2 terms, you say that there's a common difference of a constant positive value. Alright? In a decreasing, so between any 2 consecutive terms, there is a common positive and constant value. For example, 3, 6, 9, the increasing sequence term is going to be +3. So let's look at decreasing sequence now quickly, just to summarize. A decreasing sequence, right, between 2 common positive and constant value. Sorry about that. Let me rewrite this. Between 2 consecutive terms. Between 2 consecutive terms. There is a positive constant value. There is a constant value that is positive. Okay, and a decreasing sequence now between two consecutive terms there is a constant value that is negative, right? So you're just gonna put that is consecutive terms. There is a constant value that is negative. All right. Example. Let's do 9, 6, 3, and 0. I am decreasing each time by a negative 3. So those are the two main definitions for increasing and decreasing sequences. Okay, now we're going to move to a different type of sequence. One moment. Hello, good morning. All right, apology for that. Okay, now we're going to continue to the final type of sequence, which is geometric sequences. All right. Now, to explain this geometric sequence, I'm going to quickly say in a short term that in a sequence where you have to do multiplication now, so using the operation of multiplication, using the operation of multiplication, right? Using the operation of multiplication to actually find the next term in the sequence, all right? That is called a geometric one. So let's give an example. If I say 2, 4, 8, all right? This is not an even number because obviously 6 is missing. So it's not a case where I'm adding 2 each time. It's the fact that I'm multiplying by 2 each time. Okay? So let's look at it. Term 2 is equal to term 1, which is 2. So term 1 times 2. Term 1 we know is 2. So when I say 2 multiplied by 2, 2 times 2 gives us 4. Let's look at term 3, which is going to be now, is equal to term 2 multiplied by 2, which is equal to 4 times 2, and that is 8. Now, if you look on both sides, you find that the common difference between each term is that you multiply by 2. So that's the operation that we're referring to. All right? So write that for me. Using the operation of multiplication, comma, we find the next terms in the sequence when we're dealing with geometric sequences. Okay? All right? Now, there's two types of sequences, as you can tell, under geometric, which is increasing and decreasing. This is an example of increasing sequences, so I'm not going to rub this out. I'm just going to continue it to explain it a little further. So let's go 16, let's go 32. Your homework now is going to be to continue this sequence up to 8 slots. So we have 1, 2, 3, 4, 5. So we're going to say term 6, term 7, and term 8. You're going to continue these 3 slots, but I'm going to do 2 more slots for you, which is 16 and 32. So let's say now term 4. So let's write this. Term 4 term 4 term 4 is equal to T3, which you know is 8, multiplied by 2. 8 times 2 is 16, hence that is proven. Let's do term 5. Term 5 is equal to T4 multiplied by 2. We know that's going to be 16 times 2, which is 32. Alright, and your homework is going to be to continue this trend for T6, T7, T8. That's your first part of the homework. Alright, if you complete that, and I'll put it on the portal as well. So this is an example of an increasing sequence. So we'll just look at increasing, now we're going to look at decreasing sequences. Alright, decreasing sequences. Decreasing sequence. Alright, now let's follow the same trend. If when we were doing arithmetic sequence, and when we decreased, instead of adding, we subtracted by that constant value, what do you think we're going to do for a geometric decreasing sequence? If I tell you that I have, for example, 2,187, that's term 1, let's write that. Wait, let me just quickly go for another chalk, a moment. I apologize about that. Let's continue. Here's my chalk. Let's continue now. So, if I told you that when I was doing arithmetic and when we were increasing, we added, but now when we're decreasing, we did the opposite of adding, which is subtracting. If I was doing geometric and I told you to increase, we multiplied, then it must be that when we're decreasing, we divide. It's the opposite of multiply. Alright? So here we go. Let's give a quick example. On the screen you see 2187. So 2187. That's the first one. Term 1. And the next term is going to be 7, 2, 9. And the third term is 2, 4, 3. So let's try to find the trend, or the rule rather, in this case. So we're going to say term 2. So we know term 1. But let's see if we can predict what term 2 will be. Term 2 is equal to term 1, T1, and something is done to T1. If I was multiplying by 2 here, right, I need to divide term 2 by something. What divided by 2,000, what divides 2,187 and I get 729? You could have tried it and you could say, for example, T1 divided by 2, does that give me 729? And you realize that no, it doesn't. But you can try another value. You say 3 now. So T1 divided by 3. Let's quickly do that. So we're going to say now 3. Let's put it here. We're going to say 3 into 2187. All right. 3 into 2, we can't. So we look to the next term, combine it together, and we say 3 into 21. 3 into 21. 7 times 3 will give us 21, so we say 3 into 21 goes 7 times. Alright? The next rule now is to multiply these two values to get the value to subtract. So we say 7 times 3, 21. That leaves us with naught, nothing there. So then now we move to the next value in the sequence, which is 8. We need to see how much times 3 can go into 8. 3 into 8 goes 2 times, leaves a remainder. We need to know what that remainder is. So we say 3 times 2 is 6. So we're going to say 6. When we subtract it, we get 2. Alright? Now, when you look at it, we can't say 3 into 2. So we pull down the 7 and we say 3 into 27, therefore. 3 into 27, you know that's going to be 9. When you write down 3, go straight down, you will get 27. When you multiply it by 9, so you're going to say the third value is 9. 9 times 3 is going to be 27. If it gives us a remainder of 0, that means we are finished. And yes, it does. Alright? So the quotient is 729. That means this is our rule. 729. Let's try to find term 3. And if it works for term 3, then this is our rule. Because we can't just use one value to prove it. We have to use at least 2. Alright? Let's try term 3. So term 3 is going to be equal to T2 divided by that 3. If it gives us 243, we know that we're in the right. Okay? Let's try that. 729 divided by 3. 3 into 7, how much times do we go? 2 times. 2 times 3, we subtract, we get 6, so that's going to be a remainder of 1. Then now we say 3 to 1, we can't, so we pull down that 2, and therefore we say 3 to 12, that gives us 4, right? So 3 times 4, that's 12, subtract those, we have no remainders here, so we can move to the third term, which is 9, and then now we say 3 to 9 goes 3 times, no remainder. So that means our answer is 243, and that means that Mr. Thompson is telling you the truth when he says that the rule is divide by 3. So a question might ask you, what is the rule therefore? What is the rule therefore in this decreasing sequence of 2087, 729, and 243? You're going to tell me that the rule is to divide by 3. Because if you look, you see the trend. Division by 3, division by 3. That is the negative common, the negative common difference. Because we decrease by this division. Okay? So another question would be, so let me write the 2 common questions you would see. It's going to first ask you, what type of sequence what form of common difference and then finally it's going to ask you, all right, so what type of sequence, what form of common difference, and what is that common difference? So to answer question 1, to answer it, you're going to say it's a geometric sequence. Why? Because we had to multiply or divide by another value to get to the next term. Right? Due to us multiplying / dividing to find the next term. Right? So this is the type of sequence. Oh, and the final question is going to be, a part of 1, is it an increasing or a decreasing sequence? You're going to tell me it is a decreasing sequence. So you're going to say 1a, it is a decreasing sequence. It is a decreasing sequence. Why? Because we divided by 3 each term. All right? Because we divided by 3 as the rule. 2, what form of common difference? Division by 3. All right? No, sorry. What is the form of common difference? That's going to be either positive, right? Either a positive, a negative, or a fractional common difference. In this case, it's going to be what? Am I having a negative number, a positive number, or a fraction? Has to be a positive number. I am decreasing by a positive 3. All right? So that would be the answer for 2. And the third one, what is the common difference? You're going to tell me 3. All right? We divide by 3 each time. So that's the answer. That's the topic we covered today, which was geometric and arithmetic sequence. The homework is going to be posted on the portal. But just quickly, let me show you what the homework will be. It's going to be on the screen right here. Let me show you. Calculate the next term in the sequence. Calculate the next term in the number sequence, and then calculate the next term in this number sequence. All right? I'll put it on the portal though. Okay? Have a great day, everybody. By the time you see this video, it should be up before the end of the day. We apologize once again for the internet issue. And if you have any questions, just message me on WhatsApp or email.